I warmly welcome everyone. My name is Krisztián Bakon, and the title of my presentation is Production Flow of Customized Products in a Digital Factory. It gives me great pleasure to enrich the conference with my presentation. In the next short time, I would like to present the initial problem of which this research seeks to provide an answer. I want to present the hierarchical levels of the factory we have created to make the structure transparent, and then I want to present a principle of a production flow of a common product that passes through the manufacturing lines located at the hierarchical levels. Currently, Industry 4.0 is a strongly determining trend in research developments. The fourth industrial revolution has already begun, so the concept of it has already been announced by Germany, and other countries are also trying to implement it in their own way. For example, in the USA, it's called reindustrialization of the manufacturing industry. In Japan, it is new robot strategy, and in the UK, it is high value manufacturing. Because of the advanced manufacturing technologies, the whole supply chain is transforming to meet the emerging new requirements to supply the customer demands and the customized products and services. Many literature reviews address the Industry 4.0 concept, so this is an area that is now widely researched. Recent breakthroughs bring with them opportunities and results that can meet the emerging customer needs. Among such needs is the transformation of its unique production method, which is gaining ground in the field of production, bringing with it transformations that could drastically change the already usual methods in the future. We can already see that the complexity of these new systems and the capabilities they can offer incredible opportunities. Therefore, a high level of knowledge and understanding is required to design, implement, and operate such solutions. A laboratory is being built at the University of Pannonia Nagykanizsa University Center for Circular Economy. The aim is to implement the elements of modern technologies belonging to Industry 4.0 concept and to cover the entire supply chain of Industry 4.0. The concept of the laboratory contains a factory subsystem which is already built and suitable for future development and for the cooperation with companies. As it covers many technologies, the laboratory not only focuses on production processes but also wants to model other actors of the supply chain. This requires the integration of very important technologies, for example, data mining, optimization, machine learning, and sensors. It allows to model all elements involved in the complete automation of industrial processes, which creates the possibility of producing fully customized products. The hierarchy structure of the laboratory's subsystem, the factory, can be seen on this picture. It contains three layers, which are the ERP layer, the production layer, and the unit layer. On the highest level, the enterprise resource planning system contains the necessary information to start the production of every order. This layer is connected to the other layer with an interface. The production layer controls the production processes and the movement of the products and materials. It contains the production controller, which controls and monitors the status of the logistic controller and line controllers. The line controller's main task is to manage the corresponding line's performance, the execution of the tasks it gets from the production controller. The line controller's main task is to designate the appropriate machine with the completion of a given step. Every line can get a task which has to be performed, and the line controller's responsibility is to assign the appropriate machine to the appropriate task. It not only means the manufacturing machine, but the necessary movement for the production too. The supply materials movement to the machine are managed by the line logistic controller, which is almost the same authority as like the line controller, except it manages not the production, only the machines who do the transportation. In the lowest layer is the unit layer, which is a kind of a controller with the objective to controlling the machines. One machine has one host controller, so the host controller is an interface between the line controller and the machine, and the given orders are translated to the machine with the help of this host controller. So this means that the host controllers can be assigned to different other machines too, but only to only one. The figure doesn't show, but the information flow is going between the layers and the appropriate controllers. So every movement and step is monitored, and every order is being acknowledged with the response, and every finished task is acknowledged too. Because of the visibility of the subsystem, digital shadow has been prepared to do the necessary activities like the analysis and measurements, and with the help of the results, predictions can be made too. Before starting the process, I will try to briefly cover the logical structure of the system. The modular architecture of the laboratories is very important. In this way, the capabilities of the laboratory can be increased and expanded even with minor modifications. The first element of the process is the customer, who initiates the manufacturing process and gets the final product. The customer uses an interface to start the process by setting the order, where the customer can fully personalize and customize the product. An IT system assigns a manufacturing plant to manufacture the product, and one or more logistic companies to transport the raw materials and deliver the finished product to the factory and from the factory. Thanks to the IT system, there is a wealth of information available on the current state of production. For each task, it can be determined exactly which controller started and finished the current task, including the status information provided by the host controller. So, as I already mentioned, the digital shadow can be created, which is ready to be developed to a digital twin. On the picture, the main steps from ordering a product to finishing its manufacturing can be seen. An arc between two steps represents their precedence. The IC system part represents the initial steps of the manufacturing process, in which the necessary decisions can be made, like selecting a suitable manufacturer and logistic partner, preparing the required raw materials, and reserve the logistic capacity. The prerequisite of the process is a successful order from a customer. So the customer orders something in the first step. The order processing step collects all necessary data, which determine the further processes. This step is realized by with the help of a web shop in our laboratory. The production controller gets the new task, which causes it to create a new schedule. In case it already has a schedule, it needs to consider what option to be chosen to have the current schedule changed. Depending on the business policy, this may be on a priority basis or by deadlines, possibly taking into account other conditions too. For simplicity, we do not deal with multi-batch scheduling in the model. In this case, the main logistic controller is responsible for the input and output forwarding to the lines. After receiving the new schedule, the line controller creates a new schedule. This schedule is made with the tasks the line controller gets. As in the previous case, the scheduling in the production controller, the line controller's scheduling considerations are which are the most appropriate for the task of the line controller must also be considered here. Based on the decision of the line logistic controller assigns the logistic tasks to the selected host controllers, which can perform the movement of the materials required for this production. These host controllers, the movement they control are managed inside the line. If the initial conditions for starting the production are met, the tasks assigned to the host controllers by the line controller will begin. We consider the process successful if the ordered product has been successfully manufactured and the logistic partner has started delivery for the customer. The status of the product is reported to the central IT system, which provides continuous feedback, as I aforementioned. Alternative scenarios that occur during the different sub-processes should be treated as separate cases for which the procedure may also differ from the main procedure. At present, the development of our laboratory meets the initial requirements and expectations, and the functions of several parts of the companies have already been implemented, which together achieved the desired results. The structure of the laboratory is currently able to handle industrial expectations adequately. Thank you for your attention.